Okay, so can anybody confirm whether you are able to see the presentation? Okay, so we will start the session now. So welcome to the live sessions on the course Engineering Graphics and Design from NPTEL. So the course instructors for this course are Professor Dr. Sunil Kale and Professor Dr. Naresh Datla from the Indian Institute of Delhi, Indian Institute of Technology, Delhi. So this is the second week of the 12-week live sessions. So to introduce myself, my name is Vikram Balaji. I am a research scholar from the Department of Mechanical Engineering at the Indian Institute of Technology, Madras. So let us now go into this session. So for those of you all who did not attend the previous session last Friday, so I will just quickly again go through what are the detail of the live sessions. So in total there are 12 live sessions, so spanning 12 weeks. So for each week there will be one session. This session will be held every Friday evening from 7 p.m. to 8 p.m. of around 1 hour duration. So this meeting will be held in this Google Meet link which is shown here. We take the laser pointer. So it is shown here. So if somebody is not able to attend the session, then not to worry. So these videos which we are recording currently, they will be uploaded to YouTube in this channel. So this channel I have provided over here. So you can go to this channel and you can access the videos. Even in other cases, you can the NPTEL will mail you the YouTube link of these videos in a later stage. So what these sessions will do, in sessions we will involve the recap of the concepts which are learnt in the week's lecture, followed by solving of some sample assignment questions, and if any doubts are there in the concepts, we can discuss the doubts also. So these are the details of the live sessions. So in previous session we just quickly recap what we learned. So first we saw what is graphics. So we saw that graphics can be anything ranging from a small painting or a drawing or any even graphical representation of data or some kind of map, or so many things are there we saw last time. So those all can be called graphics. And in that, what is engineering drawing? We saw that engineering drawing is a technical drawing that is used to provide details about an object. So we briefly saw what introduction to the various standards which are used in engineering drawing. And after this we saw something called as visualization. So we saw how important visualization is in engineering drawing. So this leads to our discussion on projection and its various classifications, and we saw some sample questions on the spatial visualization. So going forward, we will just slightly recap what is the projections. So last class we saw that so let me have a minute. Okay. So projections are needed to represent a three-dimensional object on a two-dimensional surface like a sheet of paper or a computer screen. So one of the important thing is the principle of projection. So the principle of projection states that if any straight lines are drawn from various points on the contour of an object to meet an imaginary plane, the object is said to be projected onto that plane. So here we have an object here and a plane of projection and an observer. So these projectors are nothing but the straight lines which are drawn from the various points on the object, and they are projected onto this plane of projection. So this plane of projection, so whatever image is formed in this plane of projection, that is the called as the projection of the object. So this projection is what we will be sketching. So the figure formed by joining the points at which these lines meet the plane. So if you draw a line from this point F, it meets the projection plane at small f. Similarly, if you see, if you point E, if you draw a projection, it meets the screen at point small e. Similarly, you can do for all the points, and you can say that if you the figure formed by connecting in the correct sequence these points at which the line meet the plane, it is called the projection of the object. So the lines are called as projectors. So in this also, these we also saw that there are two cases mainly. So one case is where the object is situated in between the source and the plane of projection, and another case is the plane of projection is situated between the source and the object. So in this we can see that it is the second case, which means that the plane of projection is situated in between the observer and the object. So we also saw in the methods of projection, so we saw there are three ways by which we can define our projection method. So one criteria is the type of projectors. So they may be parallel or convergent. So in this case you can see that the projectors are not parallel, rather they are convergent towards the observer. So this comes under the convergent. Second point is the orientation of the projectors in relation to the projection plane. So this, it can be either orthogonal or oblique. So which means that the projectors in relation to projection plane. So these projectors, are they parallel to the plane or they are intersecting at some angle? So can anybody say, are they parallel, are they orthogonal or oblique? So these projectors orthogonal in the sense, if you look from the top, the projector makes an angle of 90 degree with the plane of projection. So in this case, will it be orthogonal or oblique? Can anybody tell? So in this case, whether the projector will be orthogonal or oblique. Okay, so in this case, means that the projector, so this line, it makes an angle of 90 degree. So for example, so if I draw the top view, so assume that this is my projection plane and these are the projectors. So for projectors, I will take some another color. So this means that they are orthogonal, which means that all your projectors are making an angle of 90 degree. So this another case is, you have, this is your projector projection plane. So you are looking from the top and you can see that either it will be something like some angle will be there which is not 90 degree. So is it case 1 or case 2? This case, can anybody tell whether it will be case 1? Okay, yes. So we can see that the projectors are not orthogonal. Orthogonal means that it makes an angle of 90 degree. So orthogonal. So in this case is a oblique. So third case is the orientation of the object with respect to the projection plane. So this object, whether it is parallel to this plane or is it inclined at some angle. If you see, suppose this is an object, so is this object from the top, is it parallel to the plane or is it somewhat like this? So can you say in this case, can you try to visualize whether it is parallel to the plane or is it inclined at some angle? Yes. So this case you can see that the feature of the object is parallel, but the position of the projector is oblique and there is one projection plane. So this kind of plane we can say that the projection, you can another case is we have the convergent here. So this comes under this. So if you say that your projectors are convergent and the position of the projector with respect to the projection plane is oblique, but the main features are, it can be either parallel or orthogonal oblique. In this case it is parallel and number of projection planes is 1 and this is a 3D view. So this we can call it as central or perspective projection. So there are totally 4 classes of projections are possible. So first is the orthographic projection, second is the axonometric projection, third is oblique projection, fourth is the central or the perspective projection. So among all these, the orthographic projection is the most widely used method of projection in the engineering drawing. So these are the standard which deals with the type of projections. So it's IS means Indian standard, ISO is International Standards Organization. So you can say that based on the type of projector, the orientation of the projector with respect to projection plane, and the orientation of the object with respect to projection plane. So these are three criteria based on which totally you can say that there are four. So orthographic means that the parallel projectors you have first of all. Second means you have the orthogonal, which means that it is the case 2. So your projectors will be orthogonal to the plane of projection. Main feature, it can be either parallel or orthogonal. So this, if you take this edge, it will be parallel. If you take this edge, it will be like orthogonal to the plane. So like that. So number of projection planes is you can have one or more, and this is a 2D view. So this comes under the orthographic projection. So if your projection method follows these all the criteria, then your type of projection is orthographic. So this will be more clear if you see this picture. So here we have an object, here there is a projection plane, and you can see that all the projectors are parallel and they intersect at 90 degree. So if you see from the top, this will be 90 degree. This is a orthographic view. Orthographic view is also called as multi-view projection. So second, we see that the object is not parallel to the plane, so it is inclined at some angle, and but in this case the projectors are running parallel and they are also orthogonal to the sheet projector plane. So this comes under the axonometric projection. If you see in the last picture, you can say that the orthogonal projectors, parallel projectors, orthogonal, then the feature of the object with the projection plane is oblique, and this comes under axonometric. So oblique means that your object may be parallel or it may be oblique to the projection plane, but the projectors, they may be parallel but they intersect the projection plane at some angle which is we can say that it's a non 90 degree angle, it is not orthogonal in nature. So this is called as oblique projection. Fourth one is the perspective projection. So you have an object and your rays are all convergent. So in all these three cases, if you see that the projectors are parallel to each other, whereas in this case alone the projectors are convergent. So this differentiates the perspective projection from the other three projections. So if you see, take a small cube, so you can say that orthographic projection means you will get 2D views. In axonometric you will get a pictorial view, but based on different types. You have isometric, diametric, diametric, etc. Oblique you have mainly three types. Perspective you have a single point perspective, 2 point, 3 point, curvilinear, and many such things. So in this case, if you see the object, even though the true view is shown in mostly in the orthographic, the axonometric and oblique also, you can see that there is no shape distortion is there. So whatever be the length of this line, the same length you will find here. So which means that there is no distortion. But if you see in the single point or 2 point perspective projection, so this side is of some length, but this side is of another length. Although the object is cubic object only, we find that there is some distortion of the shape. So mostly perspective projection, because of this reason, it is not used in many of the engineering graphics, engineering drawings, because this involves a shape distortion. So you can see that here also, you can see these two sides are not equal in length, although it is a projection of a cube only. So you can say this some distortion is happening. So because of this, the perspective projection is not used in the engineering drawing. So mostly we either go with the orthogonal or in that orthographic or isometric. These are the main two things we will see. So a small introduction to orthographic projection. So as we just saw, it is also called as multi-view projection. So the projectors are first parallel to each other, that is the first point, and the projectors are perpendicular to the projection plane. So if these two cases are satisfied, and viewer is also assumed to look from an infinitely far distance. So which means that if the viewer is located at infinity, then we can say that all the rays of this thing sight, rays of sight will be more or less parallel to each other. But if the observer is located very close to object, then the ray of sight will not be parallel, it will be more like a converging. So that comes under the perspective view. So the features parallel to the projection show the true length. So this is very important. So whatever is the length of this object in the real view, in the real time, so the same length will be displayed in this view. This is because we are looking parallel to the object. So whatever length is observed, the true length will be featured in the orthographic view. But one of the disadvantage of orthographic view is one single view is not sufficient to completely describe the object. So more than one view is required. So depending on the complexity of the object. So for example, this object itself, so just can you, by looking at the front, can you be able to describe this object fully? So the answer is no, because you cannot know about other features. So for example, if you are looking from this view, you may not know about this extra thing which is here, although we may show it through a hidden line, but for visualization purpose, you can say that we need more than one view to completely describe the object in a orthographic projection. So our objective is to convey the information about object in as minimum number of views. So we know that more than one view is required, but how much ever minimum, so means if you are able to describe in 2 views, then it is good. If 2 is not required, then you can go for 3. So but you have to keep it to as minimum as possible. Also your the diagram should be in a describe the object in an unambiguous manner. So there should not be any doubt when you are preparing the orthographic projection. So for example, say that you have just used 2 views. So with that itself, the person who is reading the drawing should be able to understand the object fully. So that in an unambiguous manner. So there are totally 6 conventional directions from which object can be viewed. So here you have A, you have B, you have C, you have D, you have E, you have F. So these 6 are the views, the total number of orthographic views which we generally use. So the names are given here. So for example, the A is front view, B is top view, C is a left side view, D is a right side view, E is the bottom view, and F is the rear view. So look, so the front view captures the front, the top view captures the top portion of the object. Similarly, left side view captures the left hand side of the object, the right side view captures the right hand side of the object, and so on. So you can say that it is not necessary that we need to fix only this as the front view. You can suppose say if you fix this as front view, then the F will become your left side view and your A will become the right side view. So that is also possible. So it is not necessary only A should be the front view. But when we choose, when we look at an object, when we visualize an object, we have to choose the front view in such a way that it captures the maximum number of features. So in this you can say you can go either for C or A. You can go. So in A, what is the advantage is you can be able to capture this extra leg portion. So that is one of the important feature of this object. So in this case, better we can say that A you can select as front view. So based on the orientation of front view, all other views are decided. So this is the introduction to orthographic projection. So how to capture these views? So as you might have seen in the lecture, we have something called as glass box representation. So assume that you are having an object over here, and you want to capture what is the front view, what is the top view, and all. So you assume that this box is this object is located inside the box. So then first step, you have to draw the front view. So you can say these are the red lines are the projector, and your black is the outline of the front view. So like this, you can say when you look at an object, say for example you have this pen over here. So this pen, so when you see the front view, it looks like some kind of a cylindrical thing. So, if you look from the top, you can say that it's some kind of a circular thing. So, similarly for any object you can describe what is the front view, then the top view you can say that it is on the top. So, in this case what is happening is that the views are projected in such a way that the projection plane is situated in between the observer. So, the observer is located here, which means that there are two planes possible for front view. One is this number 1, another is number 2. So, in this case what is happening is the projection plane is situated in between the object and observer. So, which means front view will be situated in number 1 or number 2. Can anybody say? Which in this case the observer is here and your object is inside. So, we are saying that the projection plane should be in between the object and observer. So, which means the plane is number 1 or number 2 for the front view I am asking. So, can anybody say whether it will be the back side or front side? Yes, front side. Okay. So, it is clear. So, here you can see that the projection is being done on front side. So, similarly the projection is here being done on the top side. So, like this you can do for, suppose you can say, so for the left side. So, suppose you are looking over here. So, I say this is number 1 and this is number 2. So, where will the left side view be projected? Can anybody say? Either it will be number 1 or number 2? Yes, number 1, correct. So, like this you can so go for this. So, the bottom view will be projected in this, suppose you can, if you say this number 3, the bottom view will be projected there. So, and you can say that the rear view will be projected in this thing. So, front view is in number 1. So, here rear view will be number 4, and you can say right side view, you can say it will be at number 2, and top view as usual we have drawn here. So, like this totally 6 you can generate views. So, 6 views I have generated. So, if I want to name this, so let me take black color itself. So, this is your front view. So, this is your top view. So, here is a left side view, and this is right side view. Here it is rear view, and here it is bottom view. So, like this we have 6 views are there. So, I have named each and every view. So, if you try to see the front view, you can be able to see this edge. So, this if I am saying this is the edge of interest. So, in the front view you are able to see the edge, but in the rear view this edge will not be visible if you are looking from the back. So, what we do is this edge we represent it as a dash line, which means that it is a hidden. So, last class we saw some standards based on the types of lines to be used. So, I told that it is available in the SP46. So, if you can check, so you have the different lines for different situations. So, like that. So, similarly, if you see the left side view, this edge, the edge which runs across, so that will not be visible. So, that will be hidden, but in the right side view, if you look from the right, that edge will be visible. So, the edge related to this extra projection, so that will be visible. So, like this 6 views you are generating, and remember in this case we told that the projection plane lies between the object and observer. So, that is very important. So, this box, what I am going to do, we are going to unfold the box. So, I have this, so this box it is a little big, so here it is little small, but you can imagine. So, this box I am going to open. So, how we are going to open is, we are going to keep the front view as our this thing. So, this is a front view. The front view is the pivot we are going to do. So, other side we are going to open. So, first of all, if I first I am going to open the top view. So, the top view, this one, if I say this is top view. So, here this top view come to top, which means that this I will take another color now. So, for example, if yellow color I am taking means, so this is the edge of pivot. So, with this the top view I am rotating to make it to align with the front view. So, front view I will again indicate over here. So this is my front view. So next, the bottom view. The bottom view also I rotated. So this is bottom view. So bottom view also I pivoted about the front view. So I bottom view it comes here. This is top view. This is front view. So we have 3 more sides are there. So what next I am going to do is the left side view I am going to bring it to front view by pivot by rotating along this pivot. So this is the pivot. So left side view comes like this. So bottom view, what happened is we rotated about this, so that bottom view came to this side. So if I were again to number, so this will be my front view, this will be my top view, this will be my bottom view, so this will be my left side view. So we have 2 more things remaining, one is the right side view and another is the rear view. So now we are going to rotate it together, so this becomes like this. So the thing which were in the right side, that is right side view, on the rear, the back side, so this came like this. So finally if we see this, I have enlarged and shown here. So finally this will be my front view, so this one will be top view, so this will be bottom view, so this will be my left side view, this will be my right side view, and this is the rear view RV. So this is one kind of projection we saw. So can anybody say what angle of projection this is? So if anybody has any idea, so can anybody say what angle of projection is followed in this case? Yes, correct. So it's a third angle of projection. So one more opportunity is there. So in this case we see that the object is between the projection plane and the observer, which is the eye. So in this case also, let me number this front as 1 and this back side as 2. So in this case front view will be get on number 2 or number 1. So remember that object is in between the eye and the projection plane. So front view will be projected on number 2 or number 1. Can anybody tell? Yes, number 2, because the object is in between the eye and the observer projection plane. So this projection plane is obviously it should be number 2. So like this I am projecting the front view. So suppose I erase these 2. So this top view we are looking from the top, so like this. So that time, so let us say this top plane is 3 and this bottom plane is 4. So where will the top view be projected, upon number 3 or number 4?
4.
Yes, 4. So like this it comes. So similarly we can project other things also. Finally we get the 6 views. So these 6 views also if you open, so again remember that what we saw here, the front view is the pivot. In this case your front view is the back side. We just saw that our front view was projected in the back plane, and top view is projected in the bottom plane. Similarly your left side view will be projected in the right hand side plane. Here will be your left side view, and your right side view will be projected in the left hand side plane. Your bottom view will be projected in the top view will be projected in the bottom, rear view will be projected in the front. So 6 we got like this. So like this also same thing, you have to open with front as the pivot. So first I opened the top view. So we remember that top view is located at bottom. So the bottom plane I open it. So this is the top view, and here is the front view is there. So next step, bottom view I opened it up. So this will be my bottom view, this will be my front view, this will be my top view. So now what I opened, we saw that left side view will be in the right side. So this is my left side view, my front view, this is the bottom view. So this is the top view. So two more are there. So this one and this one. So this will come to near the front view and this will come near to that. If you open like this, so you get total 6. So this I have enlarged. Again, this is my front view. So always remember, while opening, the front view is the pivot. Based on that, everything is there. So this was, we saw the bottom view which came to the top, top view came to bottom, left side view came to right, right side view came to left, and near to this we have the rear view. So rear view also, why we are you can draw this rear view either here also or here also, that is not a big issue. But with respect to the front view, top view, bottom view, left side view, right side view, position is fixed for this kind. Similarly, for the previous version, we saw that in the front view, the top view was at top, bottom view at bottom, left side view at left, and right side view at right. That was a third angle projection. So can anybody say which angle of projection is being followed here? This one? Yes, first angle. So we saw that was previous one was third angle. So this was third angle I told. This was first angle I told. So what are these first angle and third angle? We will look in detail. So basically, when we have orthographic projection, there are some 4 quadrants. So this is the first quadrant, second quadrant, third quadrant, fourth quadrant, and this one is the vertical plane. I'll take another color. So this one is the horizontal plane. So horizontal plane is this one, and vertical plane is this one. Okay. So we say that always the view should be from the front of the vertical plane. So this is a vertical plane, means this should be your front. So always the viewing direction is like this, and from top of the horizontal plane. This horizontal plane like this means always we should view like this. So that is how. So this is the conventional method of viewing. So first angle projection means that object is placed in the first quadrant. So if object is placed in the first quadrant means, let's say my object is, I will take another color. So say some object is in the first quadrant. Oh, sorry, I didn't change the color. So object is at first quadrant, we told. So which means that your observer is here and your object is here and your plane is here. So you can say that the observer, the object is located in between the plane of projection and the observer. So we saw that same case was here, if you remember. So here we saw that object is in between the observer and the projection plane. So this is the same case in first quadrant. In third quadrant, can anybody say what is the scenario? So here is your observer. So is the, and here is your object. So what is the, can anybody say what is the scenario in the third quadrant?
Projection plane is between the object and the observer.
Yes, correct. So your projection plane is in between the object and observer. This is exactly what we saw in the first case. This case, we saw that the here this is the plane of projection is in between the observer and the object. So this is how we are projecting. So in this case, while projecting, we saw that the object is in between the observer and the plane of projection. So back side is plane of projection. So always remember that he made a convention, so that you should not forget. Always a view should be from the front of the vertical plane and the top of the horizontal plane, like that. So third angle projection we just saw, the object is placed in the third quadrant and the plane of projection is placed between the observer and the object. So other two quadrants are inconsistent. So can anybody say why it is inconsistent? So just we saw that these two cases. So in this case object is between observer and plane of projection, and in this case a plane of projection in between observer and object. So for second quadrant and fourth quadrant, can anybody just guess why there is an inconsistency? Okay, so I will tell you. So assume that the object is placed in the second quadrant. So if I look from the front, so in that front what I am seeing is that my projection plane is between the object and observer. But when I look from the top, the object is between the projection plane and observer. So this is the reason for inconsistency. In the first quadrant and third quadrant, we saw that either case. So object is placed between observer and plane of projection is first angle projection, and plane of projection is placed in between the observer and object is third angle projection. But if you see second quadrant and fourth quadrant, in one case when you are viewing from the front, it is the one different case, and if you are viewing from the top, it is the opposite case. So this leads to the inconsistency. So because of this, most of the engineering drawings either use the first angle or third angle projection. The other two angles of projection is not used. So this is the reason. So any doubt till now? Any doubt in what we discussed? So about the basic of orthographic projection. So any doubts are there? So if there is no doubt, we can slightly proceed further. So this is the end summary. If you see that first angle projection, we saw the front view, bottom view is at top view is at bottom, left view is at right view is at left, then back view is there. So like this. Then similarly for third angle projection. So this is the summary. So first angle projection, we just, what is the differences? So you can just see this. The object is kept in first quadrant, here is in third quadrant. So here the object lies between the observer and the projection plane. Here the plane of projection lies between the object and observer. So here you can see the plan comes before the elevation. So plan is nothing but, so in sometimes in engineering drawing, if your top view will be described as plan. So you have a plan of a house, for example. So you say there are different floor plans are there. So this plan always denotes it's a top view. So suppose you are going to some big complex building is there. There you are seeing something called as emergency floor plan. You might have seen that. So that floor plan will say where are the emergency stairs located, where is the elevators located, where are the different smoke detectors, or where are the different fire extinguisher, where are they located. Those things you will be able to see in the emergency floor plan. So plan always means it is a top view. Elevation means you are able to see the height of the building. So height you can able to see only in the front view. So front view is called as elevation. So in this I don't think there is any doubt. So always remember, elevation means front view, plan means top view. So here we saw in the first angle projection, the plan comes below the elevation. The plan is nothing but top view, it comes below the elevation. Here the elevation comes below the plan. So this is the one very important difference. So usually first angle projection, European countries and even in our country, I think mostly first angle projection is followed, and if you see US and other countries, they follow the third angle projection. One important thing, third angle projection is intuitive while first angle projection is counterintuitive. So this is reason why this is so, because in third angle projection we saw that the top view is located at the top in the third angle projection. Top view is located at the top, bottom view is located at bottom. So this makes sense. But in the first angle projection, top view is located at bottom and bottom view is located at top. So we saw why this is the reason, because of the projection method. But if you say to somebody who doesn't have any knowledge of engineering drawing and projection, if you say that bottom view I have drawn at top, he will say, why you are drawing at top, you can draw in bottom. So that will be one of the obvious questions that we will ask. So because of that, this third angle projection is more intuitive. So that is what I meant in this statement. Okay, we will now solve some.
Some mean by intuitive.
Intuitive means it makes more sense. It means it is obvious, like that. Okay, so I forgot to mention this thing. So whenever you see the drawing of any drawing, if you have, you can see that in the bottom there will be something called a title box. So in that they will say what are the scale used, what is the title of this drawing, so like that. So other than that, they will provide something called as projection symbol. So always first angle projection means, so this is your symbol. So why this is a symbol means, you say you are having a frustum of a cone which is in a sleeping position. So which means that it is, the axis is horizontal, the left side is a smaller dia, you can see here, this is the left side circle, and the right side is a bigger dia. Okay, so can anybody say this thing, you can you know that the the left side view, it will come in the right side or left side in first angle projection? Can you just discuss now? Can anybody recall left side view, whether it comes in right side or left side? Right side, correct. So because of that, if you see in this way, left side view, so your small circle is coming, then your big circle is coming. So this is your left hand side view and this is your front view. So left hand side view coming to the right hand side of front view, that means it is a first angle projection. So in this case, object is a third quadrant, front view is like a kind of a trapezium, and left side view is projected on the left side itself. So here you can say that the left hand side view is over the left of the front view. So if you see the symbol, you should automatically understand. So this is your front view. If you are looking from the left and you are projecting it in the right hand, you are projecting it towards the right, that means it is a front view. So similarly, this object, you are looking towards the left and you are seeing the two concentric circles, and that projection you are drawing in the left hand side, that means it is a third angle projection. So this is the way to understand whether a given drawing is a first angle projection method or a third angle projection method. So this is one important thing. So now let us solve this question. So can anybody say which is the front view? So I have 6 options. So A, B, C, D, E, F are there. So front, so this is my direction of view, I have indicated like this. So this means like, so we just saw, so if this is front, this is the direction of view, means it is a front view, and others view are like this. So yes, C.
C is the front view.
Okay. Yes. So because if you see here, you can see that this, yes, correct. C is the answer, because the circle is will be visible, and second case is these edges also will be visible. So it is a thick, it is not a, it's a continuous line. So this is your answer. So top view, can anybody tell which option?
A. Yes, sir.
A. Okay. 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 I think some echo is coming. Okay, no problem. So generally this is for the, in the multi-choice question, that is okay, but generally when you are representing kind of a circle, you always, the center you have to give some plus symbol, and the axis you have to denote like this. So it is a long line, done dot line. So this is center line, and similarly you can say that here you have to draw the long line dot like this. This is the center line. Okay. So just assume this is just for a visualization purpose. So I have not indicated any of these lines. So anyway, so left side view, can anybody say which is the view?
D, sir.
Okay, correct. Because yes, in the left side view you can see that this L orientation is like this. So that is there, and similarly this edge will be invisible, and this circle also will be invisible. So it is this case. So right side view, B, because in right side, yes, because in right hand side the L orientation will be like this. So you can say bottom view, which means you are looking from the bottom. Yes, It is F.
Okay.
Yes. So rear view, so only one option is there. So it is option B. Yes. So like this in your assignment also you can see that similar question will be there. So you have to correctly identify which of the view. So it is just a exercise in the visualization. So same question. So can anybody say which option represents the first angle projection? So you have to first identify what is front view, what is top view, what is left side view, right side view and all, and see the relative orientation of each other. And we always saw that in first angle projection your top view will come below the front view. So that you have to keep in mind.
Option B.
Yes. So this is your front view and this is your top view, and in this case the top view comes below the front view. So because of that you can say that option B is the first angle projection. And we saw that this is our left side view, it comes to the right hand side. So that is also this thing, that is also the reason. So option B. Okay, third angle projection, same solid. Yes, this is your front view. This is your, are you sure it is option A? This is top view. Your, okay, this is your left side view.
Yes, sir.
But so okay, one more thing, the side view, does it come next to front view or does it next to top view in any angle of projection? If you just saw, can you recall?
Sorry, option B.
Yes. So are you able to see the reason? Because always your left side view, no doubt that left side view should be come in the left hand side, that is one thing. But always in any projection, if you just to recall, just I will slightly go back, left side view, right side view, always it is comes near the front view, because while opening the box we saw that we fix the front view and then open the box with respect to front view. Here also if you see, just for the sake of this thing understanding I am going, the left, this side view always comes with the front view only. So you have to, that also you should be careful while seeing the problem. So you should understand that the whichever is the front view, the either side view, left side view or right side view, it should be next to the front view, and top view is above the front view. So option D is the answer. Okay, so this is some small source of confusion may come, so you have to be careful while doing the assignments. So now I come into the isometric projection. So isometric projection means it is a pictorial view of the 3D object on a 2D surface. So one of the main aspect is, suppose if you say this is a cube, this is my x axis, this vertical is my y axis, and this point is my z axis. So if you extend the lines, suppose if you extend this y to like this, you can see that this angle will be 120, this angle also will be 120, this angle also will be 120. So since the in isometric view all the three axes are equally inclined, so that is called as isometric. Iso means it is equal, so that is the meaning of iso. So in isometric projection all the three axes are inclined to each other. But one small problem with isometric projection is the feature of the solid. So you can say that how we are getting the isometric projection is, you are inclining the object with respect to the plane of projection, but the projector planes are parallel. So since this is inclined, so suppose you say that you are going to take the length of this, so this it will be projected like this and this will be projected like this. So you can see that this length will be slightly different, the projected length is always different. But in orthographic projection always you saw that we are getting the true length in the projection. In isometric that is not the case. So even though the axes are equally inclined to each other, and we are able to get the 3D representation. In isometric, in orthographic we always have this a 2D representation, which means one view at a time if you take, it is only a 2D. But in isometric you are able to show the depth also. So three axes you are able to show, which means the length, breadth and depth all you are able to show in a single view. So that is one advantage. But one disadvantage is that the length is will not be same. Yes. So suppose you are say this will be a 5 mm in the real time, but when you see in this case, if you try to measure this, it will not be 5 mm, it will be something else. That is because of the angle of projection. So because it is not orthogonal or it is not parallel, there is some reduced length is there. So that is the issue. So if you want to visualize how the isometric is arrived, means suppose for example take a cube. So when you look at the cube just from at the front, say like a orthographic, so what object will you able to see? Anybody? So you are having a cube, yes, it's a square. So it's something like this, it's a square. So suppose same square, so assume like this is not like a square, but it is similar to a square. So this object, now what I do, I slightly incline it in a horizontal. I am not inclining in vertical, I am inclining in the horizontal. Now you will be able to see how many faces. So earlier you saw only one face, so now how many faces you will be able to see if you are looking from here? Anybody?
3 faces.
3. Are you sure? Because I am just inclining horizontally. Yes, so this face and this face, still this face you will not be able to see. So if I say, so it will be like this. So you will be able to see this edge, and you will say this face and this face. So can you say this face will be suppose 5 mm, but what I draw here, this length will not be 5 mm. Why? Because it is some angle, and that cosine of that angle only it will be projected as a this thing. So for example theta is 30 degree you are inclining, so cos 30 like that length will be coming. So this is 2. Now what I do, this from this stage I incline to like this. So now how many face you will be see? So now you will be able to see 3 face, because this face you see, this face you see, and top also you are able to see. So that's how the isometric comes to view. So now earlier if you see through orthographic, only one face you saw. After I incline it, you are able to see the second face. Now I slightly tilt it in the vertical direction, so you are able to see the 3. So how the tilting I am doing is, so here some tilting and here some tilting. After the tilting, if you observe all the axes are equally inclined to each other, that is called as isometric. So simple. So I have cube, first look it like this, then tilt it horizontally, then tilt it vertically, then ensure such a way that all the angles will be equal. So if you see this point, this vertex, if you see closely observe this vertex and this exact body diagonal opposite vertex, they will be coinciding with each other. If you see, for you look at it. So if you have any cube with you, you just take it, view it in one sync, you are able to see one view, then slightly view it like this, and then slightly view it like this. So such that your body diagonal, this point and my point, almost it is in the straight line. So that is the isometric projection. So that's the thing. So another case, what happening is, I view this, I slightly incline vertically. So vertically how I incline, one I incline like this, so you are able to see top face. If I incline like this, you are able to see bottom face, this face and bottom face. So that is what is shown here. So here bottom face, so this is your bottom face 3, this is 1 and this is 2. So either 1 to top face or 1 to bottom face. So okay, so this is the thing, this is the isometric projection. Here if you see, this is 1, this is 2, this is 3, so it is top face. So like these are there. So usually we prefer this top face orientation to bottom face. Why? Because, so suppose your axis is like this, you can say this is your sorry, I will draw the axis in bottom, x, this is my thing, y, and this is my z, and in this you can say this is my x, this is my y, this is my z. You can use both method, but generally we prefer the top face orientation. So that is not this thing. So you can use both. Top face will be more easier to understand because the axis all will be somewhat easier to identify. Here you can sometimes get confused. So because of that we use like this. Okay, see now we are looking at something called chord plan. So chord plan means it is a tool to visualize and sketch the isometric view from the two-dimensional chord. So you have some basic unit cube. So this is my small cube. So like this, many cubes are there. Suppose you have some that building block we used to play in when we were child. So like that you assume. So I give some number 1, 1, 2, 3. This 1 means that there is one block over here. This 2 means that there are two blocks, one on top on each other. Here there are 3 blocks, one top of each other and another on top of it, 3 blocks, and this is your one block. So I told means plan is a top view. So from the top if you look, you are just giving the number. So one block over here, 2 cubic blocks over here, 3 over here and 1 over here. So from this how to get the ISO view. So for this there are some steps. So first you have to decide the direction from which the 2D plan is to be viewed. So there are 4 directions are there like this. So you can view like this, you can view like this, you can view like this or view like this. So as I told you, isometric means if you view straight it will become orthographic, but when you view like this inclined, so like this, so then you get isometric. So for this we have 4 ways. So you have to represent the plan in isometric grid sheet. Grid sheet I will just you can, if you search in the online itself, you just ISO grid sheet, you will get lot of things. So for example I will show one thing. I go online, so ISO grid sheet, if I type, so this you can get images. So if you are having some tablet or something, you can download this image and you can draw this. So for example you have some sheets like this. So in these sheets you can say the full template you can get. So like this you have 3 axes, so vertical, then one like this and one like this. So graph paper. So like this you can get online. So now coming back to this PowerPoint, so you have to represent this plan, then you have to stack the cube in the ISO sheet as per the plan, and you have to next you have to erase the extra edges and retain only the edges where the surface, 2 different surfaces are intersect. So I will explain now. So this is our 2D space, this is the coded plan. So 1, 1, 1, 1, 1, 2, 3. So next like this you have to draw. So you have an ISO sheet means, so let us say I am looking through this angle and this direction. So for me here the 1 will come first, the 2 will come at the left side, the 1 this will come in the right side and 3 will come back side. So this is the plan. So if you are to view from this direction, let us say, so similarly I am drawing like this my plan. So can anybody say what will come here in this space if you are looking from this direction? So which number? Yes, 1. Then from here what will come? Any idea? Which is to left side of 1?
1, 2.
Is it 1 or 2? So here again you have to so this is your direction of view. Here first one you have done. So second also if you see this side you are having 1, 1. So here which side, which number will come?
3.
3, and this will be 2. So like this you have to view, you have to first fix the direction, and then this same you have to like this in a sheet you have to do. So second thing is you have to roughly number of cubes you have to stack it. So for example so here is 1 is there, so here 1 cube I am stacking, here 2 cubes are there. So next to this I am stacking 1 on top of each other, so this will become 2 cubes. In third side again 1 cube, and fourth side you can see there are totally 3 cubes, but why it is showing 2 here? Can anybody say why? It's, you can see only 2 are there, but 3 should be there. So yes, correct. So yes, basement. So this cube is hiding the basement cube. So like this you have stacked 1 1 2 3, same 1 1 2 3, like that you have done. So this, then what happened? So any surface means, suppose this is one surface means, in the between lines you have to erase it, and then you will get a smooth object like this. So this is how we have to do. So one sample we will try now in this. So if you have any ISO grid sheet with you, or you can, for the time being you can try it in paper itself. So suppose we saw same thing we saw in the x direction. So can anybody in the y direction, first of all can you tell what will be this thing? So y we saw, let us, y also I think we saw in this case. So let us say you are doing z. So like this we have to plan. So from z if you are looking, so what will be the nearest here? Can you anybody say? Yes, 3. So to the left of that you are looking from here, then left side. So which means
1.
yes. Back side
1.
1 or 2. So you see from here this 3. So if you see like this, so this is front means this is back. So yes, 1. Yes. So this you have to visualize properly. So this will be 2. Okay. So now I have done this. So next I will try to do in this paper. I have this sheet. So first of all I have 3 cubes I have. So first I will draw 1 cube. I think I already selected green. So let me draw on red. So like this slowly you can draw. So this will, you can see. Even you can also practice this. If you can, either you can buy ISO grid sheets like manual ISO grid sheet, or you can try like this. So this is 1 cube. Again on top of this I draw 1 more cube. Again on top of it I am drawing 1 more. Yes. Okay. So the edges we will erase later. First we will stack the cubes. So here how many cubes will be there in the right hand? 2. Okay, correct. So like this, one cube, and like this 1 cube, and this will go like this. So okay, so 2 cube others. So I will slightly otherwise if you are having any tablet and if you are having any like stylus also, that will be more easier for you. Here I am trying to do in this thing. So here there will be 1. Yes. So here back side, will it be visible, this one? Because you already have stacked the 3 here, so because of that it will not be visible. So I will try to erase the small things. We will make it into a single surface first. Here also I think we can erase this also, I think so. Okay, I will make into like this. So this is the final object. So are you getting it? So is this okay, this final object? Okay, so this is the final object. So similarly you can try for W, and if you are able to do it, if you have some sheet with you, you can just do it quickly and you can show me, like you can temporarily you can open your screen and you can show it to me if you are able to do. So I will just go over here. So can anybody do quickly and can you show it? Okay, are you able to, you have something with you, some rough sheet or something? So you can also try it. So W I will just so this was for Z. So W also you try it. I will just give some 2-3 minutes. You try it first. You have to always put your plan like this, code plan. Okay, for code plan alone we will discuss for W. So if you are looking from W, what will be your first nearest one? Anybody? Hello? Yes. 2. Okay. I think there is some delay in the audio because there is some gap is there. Okay, anyway, no problem. Okay. So this is 2. What will be your left hand side? So this is 2 means to that left hand side what will be there? 3. Okay. So here 1 and this will be 1. Okay. So which means you have to, I think some echo is there, so because of which there is maybe issues there. Okay. So you have to, the plan means first you have to draw 2 cubes in the front and next to the 3 cubes and 1 cube in the side, and this anyway will not be visible. So I'll just give 2 minutes, you just quickly try to show. I will keep this open so that if you are opening your camera I will be able to see. So I'll just give 2 minutes. If you are able to do it, do it. Otherwise I will do that and I will show you how it will be. Just 2 minutes I will give. So anyway we drew the code plan we drew. So just you have to stack it. So if you are able, if you have ISO sheet online or you are able to do it, okay. Otherwise you show it in paper and like this. So for example this is a notebook, means you can draw like this and you can show it like this. So in this notebook you can show it if you are doing in rough sheet. I suggest some people, for practice purpose you can buy ISO sheet. It is I think available in many stationery shops, it will be there. So you can practice these kind of code plans in the this thing, ISO sheets. So is anybody trying or shall we?
Can you please show the code plan?
Yeah. Okay. So this is the code plan for W. We discussed 2 cubes in front, 3 in the left, 1 in the right, and anyway this one won't be visible. So I actually came to this one because if somebody is opening your screen so that I will be able to see, otherwise I won't be able to see if I am in the presentation, because of that. So once again I will show the plan, you quickly see. Okay. So if anybody is ready, you can just alert so that I will look this. So meanwhile I will also try it over here. So for who are not able to do, so we will see how to go about it. So if you have done, you can just alert me. I will quickly come back to this meet and I will see what you. So 2 cubes. This is. So this is little shabby because I am doing freehand. Maybe in some other case you can be able to do, like if you are having tablet, means that is best, because you can, if you have some stylus, you can do it like this. you can use that thing. You can, so 2 here, the 3 in my left side. More top row. Here there will be 1. So we will try to erase the in between surface. This will be not there. So also won't be there. This won't be there. This won't be there. This won't be there. This won't be there. Is this okay? I think this also. Is this what you got? Something like this? 3, 2, 1. Yeah. Okay. So we'll quickly see this thing. W. So I think this is this is same as what we got here, no? So W is there. X we saw. So this will be your Y. This will be your Z. So you can take some simple thing. You can develop your own code. So for example, you say this is a thing. You not necessary to 4x4. You can have even 6x6 also. So you can just for practice you can. So like this you can see. So you can say 1, 2, 1, 3, 1, 2, 1, 1, 1, something like this. So you can view in this direction. So if you view in this direction means in the left hand side you will be have 2, 1 in right hand side like this. This will come in the back. So like this you can increase your complexity and you can try to do this. Okay. So is there any doubt in this code plan? So is this okay till what we discuss? So we can slightly go further. I think this almost okay. We will see some few more sample questions and we will quickly wind up the session. So you have this thing, you have this isometric view with you, and you also have the code plan. You have to just provide for each case what is the direction being viewed. So this is your isometric view and this is your code plan. So can anybody say which is the direction of view for this? So suppose if I am viewing, so my 1 is in the right hand side, and here also there is a 1 and there is a 3 in the middle and 2 in the right hand side. So which is the view which best represents? Can you anybody say? X. Okay. So X is like one option is there. So in this option if you see, there is 1, there is 3 and 2. The 3 and 2 are coming in the left hand side. Okay. But in this case this 1 is there. Okay. Okay. W. Okay. If you see in the left hand side, 1 is there, 3, then 2 should come if you see. But if you look here, 1 is there, then 3 is there, and to that left hand side of 3 only there is 2. But here to left of 3 there is 1 only. So W is answer. So did anybody any doubt in this? So why X is not answer, why W is answer? So did you get it? Because if you view from here, first you are seeing a 1, then you are seeing a 3, and then you are seeing a 2 in the extreme corner, and again next to it you are again seeing a 1. So if you are viewing like this, so W is the correct one. So can anybody say for B, option B, which is the view of direction. So here we have 2, here we have 2, sorry, here there is 2, there is 3 over here, there is 1 over here, and again there is a 2. So, huh? Yeah. So, okay. Sorry, this 2, then 3, 1. So, which? Okay. Correct. So, 1, 2 in the left, 1, 2 in the right, and 3 also in the right side, 1 is there. So, these 2 will not be visible, back side. So, Y is the answer. So, can anybody say for C? So, C is little complex. So, let me write. First, I have 2 over here. Then I have 1 to the left hand side and 1 to the right hand side. So, there is a 2 on the back. So, I think I heard some answer. But Z. Okay. So, this because of this only you are getting a 2 in the front as well as in the back. So, this is Z. Okay. Okay. Is it Z or there is one more option is there? So, here if you see Z is not the answer. If you see,
2 and are the diagonally opposite.
yeah,
We should not see.
yeah. So, I think X is the answer. Is it correct or?
It would be also wrong then, because 2 and 2 are again diagonally opposite.
So, okay. So, you check this thing. So, let me once again draw this one. So, here first you are having two boxes, and to the left hand you are having one box. So, here again you are having one box.
We are having 3 boxes also at the back, but in the option it is only a combination of 1 and 2.
I think if this there is some error is there, I think. Okay, we will because there is a 3 is there, so I think there is some error is there. So okay, we will not look at this. Okay, so we will try this one then. D we will try. So first box is I have 2 over here. To the side I have 1 and 2, 1 in this side and 3 at the back. So which is the option? So 2 in the front, 2 1s in the front. Yes, X, correct. Okay, so like this you can try to look at various options and you can see. So this is one sample question we saw for identifying the direction. So now we will see for this plan which is the following isometric view. I think
I did.
okay. So this is my plan 1 1 3 2. So this A what direction it is? So first I am having, yes, A is Y. So so Y is a A. So B, so I have 1 here, 1 here, 3 here, 1 here. Yes, correct. Okay, so B was X. What about C?
Public.
Yes. So Z will be your D option.
Yeah.
Yes.
will be
So you have to check properly. So we'll see once again.
it will be D, I think.
W and D and Z and C.
Okay, we will see, for example, C we will see. So I am having 2 in the nearest, and I am having a 3 to the right hand side and 1 to the right hand side. The back one is not C. So C will be Z, right? Yeah. So this W will be D. So we will again check it for purpose. So we have a 1 over here, a 1 over here, a 3 to the left and a 2 to the extreme left. So okay, correct. So this is the correct answer. So any doubt in this question?
Yes.
Okay. So Vijay, yes sir. So Vijay sir, you can ask the question. So you have raised a hand. Vijay sir? Hello?
Hello, it's all right, sir. No problem.
Okay, okay, okay.
Thank you, sir.
Yes, yes, yes.
Thank you, sir.
So we have last one and 2 questions. So this is for the rotation. So this is my isometric view. So I have 3 axes: x axis, y axis, z axis. So if I rotate about some axis either in the clockwise direction or in the anti-clockwise direction, so I will get some result. To get A, so how should I rotate this object? About which axis and in what direction? Is it a clockwise or anti-clockwise? So that, can anybody say? So
Y-axis in the clockwise direction.
about y axis, this one. So about the axis means, suppose if you are considering this your y axis, suppose if you rotate it, this portion will come in the top.
Y-axis in the anti-clockwise direction.
Okay. Okay. So y
90
axis.
plus 90.
Okay, so first of all, just before going into it, I have to say one thing. So if you are rotating about y means, so this will be your rotation, correct? Or it could be like this, if it is clockwise or anti-clockwise, like this. If x means, it will be like this. If it is z means, it will be like this. So for example, say take this triangular projection. So if I rotate about the y axis, this triangle will come upside, or will it come right side, or it will go some other. If I rotate about y axis, yes, upside, or it can be go for downside also, depending on how we are rotating. Okay, so is this possible in y if you rotate about? So you have that projection is,
About X-axis,
yes,
we have to clockwise.
okay, and it is a clockwise, correct. So this is x and I am writing it's a CW, which means clockwise. So are you getting it? So this is your x direction, and this will come like this. So then only this vertical become horizontal. Are you able to get it? Yes. Okay, so B option,
Y-axis clockwise.
y axis, okay, and it is a clockwise, correct. So clockwise means you are going in a clockwise direction, which is means this going in a clockwise direction to top. So this triangular chamfer is in top condition, in the top. So this is a y CW. So for C option,
Z-axis clockwise.
okay. So yes, which means that, yes, clockwise. This chamfer is going to the behind. So which means that it is rotating about the z axis. You are going like this fashion. So this is z. Is it clockwise or anti-clockwise? Yes, clockwise, correct. Okay. So these 3 are done. So I think this you can do it. So this is in the right side now. So what?
X anti-clockwise.
Yes, correct. So CCW I will write, which means that it is a counterclockwise. Counterclockwise means anti-clockwise. So okay, so this one, if you rotate about x, so either this can come to horizontal right side or it can go to horizontal left side. So if you always use the right hand thumb rule, so right hand thumb rule means you see whether it's a clockwise or anti-clockwise. So it is a counterclockwise. So E option, which can you say?
Z axis counterclockwise.
Yes, Z axis CCW. F, only one option is remaining, Y counterclockwise. So like this also you should be able to identify. So if you are having isometric object and you are rotating it about an axis, you should be able to visualize. So this is one question. So last question before we wind up this session. So you have to say about which plane. So you have three plane. One is, this is your xy plane, this is your yz plane, and this is your zx plane. About which plane this object is a reflection. So you are mirroring the object. About which plane you are mirroring it? A option, can anybody say about which plane it is mirroring?
X axis.
You have to say which x axis, okay, but plane means it is a xy, yz, zx like that. Yes. Is everybody okay with yz, or is it some other answer? So one thing you have to see is that if you are going to reflection, you observe this chamfer. This chamfer going to the back side. If you are is going to back side, so which means that it is reflected about the yz plane. Then only this front goes to back. So the yz is answer. So in this case, B, you have to look at this chamfer.
X and Z axis.
Yes, so it is a xz plane, correct? So if you are having the mirror over in the xz plane, so this chamfer going to left hand side like this. Okay, C option, this chamfer coming to top, so it is a xy. So if you are reflecting about xy plane, this chamfer comes to top like this. So this session we saw some case, we saw the introduction to the orthographic projection, some sample questions we saw, then isometric projection we saw, how to develop the isometric projection for simple shapes using some code plan. So my one thing is, you can develop your own code plan and you can try to sketch it in a grid sheet. That will be very useful later. So and we saw some rotation and reflection problems also. So with this we will wind up this session. So any doubts you have or any suggestions for the session? Is this session okay like that? Anything? So for this okay, thank you. So for this week 2 we have seen these kind of things. So whatever is discussed in that week, based on that we recap the concept and we solve some sample questions. So with this we close this session. So any doubts are there? If anybody has doubts, you can ask, or we will close the session. Is everybody okay?
Yes, sir.
Okay sir, okay everybody. So have a good weekend. So thank you for attending this session. We will meet next week same time. Yes, 7 to 8. Okay, thank you. Okay, bye. So I will stop the recording.